Hi everyone, and welcome to this Valkyrie sound tutorial. In this video we're going to use Quartz to play a seamlessly looping and layered musical soundtrack. Every time we dispatch a zombie, we'll fade out one layer of music, and we'll set this up so that the fade is always synchronized to the beat. When all the zombies are more dead than they were before, we'll reset the music and start over. This setup isn't just for music in combat. You can strip that part away and use this to simply loop some music, or you could define other criteria to create anything from Geiger counters to spaceship proximity alerts, metal detectors, and audio prompts for players about their stats. To demonstrate the versatility of the setup, and of Quartz, we'll create the fabled motion tracker from Aliens, with bleeps synchronized to the beat, which raise in pitch when enemies are nearby, just like in the film. I'll also show you how we can use Quartz in on-screen HUD animations so that we can give an audio-visual cue to the player about the proximity of nearby zombies. So first of all, what is Quartz? In layman's terms, Quartz allows us to trigger events at specific intervals. They can be audio events, but we can also use Quartz impulses to drive other behavior as well. That's really useful if you want to synchronize sounds with each other, and also if you want to synchronize events and sounds together. If we have a minute-long piece of music, and we want to loop it seamlessly, rather than processing it in an external app and then bringing it into Unreal, we can tell Quartz to simply play that sound again when the first sound finishes. And with the right setup, we won't get any clipping, we won't cancel out our original sound. We can overlap our music so that we get a seamless loop. The key thing to remember is that Quartz will always fall on the beat you specify. If you need something to happen on the first beat of a particular bar, Quartz can make it happen. So first of all, we're going to create our Quartz system. Now technically we could build Quartz in one blueprint and create another blueprint to specifically manage the behavior of the music when the zombies die. But I wanted to keep this reasonably straightforward, and I wasn't sure if that might overcomplicate things. So we're going to do the music and the fades in the same blueprint. So in the event browser, right click, I'm going to create a new blueprint actor, and I've called mine BP Death Music. So this is what it's going to look like. From our event begin play node, we're going to get a reference to the character blueprint. That's the first person character for me, it might be third person for you, and we'll cache a reference to that so we can use it elsewhere in the blueprint. Next we're going to create a custom event called Start Quartz. What we need to add in here is the call function to that event. Next we'll create a new function and we'll call this set fade duration. Now from our Start Quartz custom event we want to add the create a new clock node. Now this might not show up if you have context sensitive ticked. The target is the Quartz subsystem. The clock name, you need to enter a default value in here, otherwise the clock won't work. I have promoted it to a variable, so we can access it if we need to from elsewhere in the blueprint or from other blueprints as well. And I've called this one bread, because that's what I was eating at the time. The in settings is where we're going to specify the time signature. So from in settings, we want to make Quartz clock settings. So we can just type in clock and get that. From the time signature input, we want to get make time signature. So get that node. And I've set the number of beats to a value of 4. And then I've right clicked on that, promoted it to a variable, which I've called beats per bar. For the beat type, you'll see here we've got /4, that's our quarter note. /2 will be our half note, /8 our eighth note, and so on. I've also promoted this to a variable, and both of these are editable. I've got the instance editable here for both of these. The more editable options that we give ourselves, the more easy it's going to be for us to pick this blueprint up and use it in another project. So whatever time signature we specify in this section, it has to match whatever the time signature is of the music we are going to use. My music is in 4/4 time. We're going to promote the return value to a variable. I've named mine music clock ref. Next we'll add a set beats per minute node, which allows us to determine the BPM. Again, this needs to match whatever the BPM is of our original track. I've entered 120 in there, and I've right-clicked that, promoted to a variable, and made that one editable. And that's our first section done. Next, we'll tell Quartz what to do when the clock first starts to tick. So the first thing we need to do is to set up our sounds. So this is a new function. If we go into that, this is what it looks like. We are taking an array of sound base assets, and for each entry we are setting a sound, setting an audio component sound in our list of components on the upper left here. We then add that sound to a new array, an array of audio components, and we do this twice, and we are adding the same sound into both arrays. That gets us the seamless loop I mentioned earlier. At the appropriate point in time, Quartz will start playing all the sounds in the second array, and that means we get the reverb and natural fade out of all the assets in the first array with no harsh cuts or abrupt stops in our music. So you might be wondering why we're making this conversion. Why are we going from a sound base array and then converting this to an audio component array? Well, the simple answer is that although Quartz will take an audio component and it will take a sound base, we can only edit sound bases outside the blueprint in the main editor window. We can't edit the audio components unless we go into the actual blueprint. So by creating a sound base object array, we can drop the blueprint into our map, and in that main window, we can adjust, edit, delete any of the sound assets that we put in there. If we drop this blueprint into our map, like that, we have our empty array here for the sounds, and we can pick an asset up and we can drop it in. It can be a WAV file like this. We can create that into a queue, and we can drop that in as well. If we use an audio component array, if we make that editable, expose that on the main screen. Here it is, stored sounds 1. This is our audio component array. I can't drag any sounds in there. It can only be used with audio components, and we can only have audio components inside the blueprint. So let's go into this. From our set sounds input, we are going to add 2 clear array nodes. And we'll need to create 2 audio component arrays for this. So that is new variable over here, and we want audio component object reference, and the speaker icon becomes an array. We need 2 of those, and then we just drag them and hook them up to the clear nodes. When we pick a zombie off, we'll fade out that particular music track corresponding to that number of the zombie. When we pick off a zombie, we'll fade out one layer of music and remove that layer from the audio component arrays. But it's possible that we'll still have some entries in the arrays when we start a new round. That's because, as you'll see shortly, we're not removing the asset from the array until it's been fully faded out. So when we're starting a new round, we need to tidy up the arrays, emptying and then repopulating them. Without these 2 nodes, whatever items are left in the arrays at the end of the round would be carried over, and that affects what sounds are then loaded in on this next section. It won't be able to load them all in because the array isn't properly empty. So next we're going to add a sequence node, and that's because we are doing 2 sets of sounds. We are doing a sound for our music from one track to the next, and then we have a section down here for the one-shot sound that's going to play at the beginning of every round. From the first output pin, we're going to add a for each loop node. We need a new variable, sound set, and that is our sound base array. So sound base, object reference, and it will be just the lozenge, but we want to change that to the array icon. That's the one that we need to make editable, so we can drop our sounds into it. We're going to plug that into the array input of the for each loop node, and then we're going to drag off and get a length node. From the array index output node, we're going to add an equals node and hook the lower pin up to the length of the sound set node. The for each loop node will cycle through the sound set array, and when the current index matches the length, we'll know that we've already reached the end of the sound set array list. It won't try adding more sounds in. From the loop body, we're going to add a branch node. I know it's a bit tricky to see everything here, but we're going to add that from the loop body. We're going to add a branch node in, and we also want to connect the Boolean output of that equals sign, of that equals node, to the condition input of the branch. We're going to leave the true output empty, and from the false output, we're going to add a do n node. This limits the number of times the execution pulse will pass through to the next section, so that we are only passing through as many times as we have entries to complete. If we have an array of 6 sounds, 6 pulses will pass through. So the n input needs to be connected to the length output. For the for each loop, the completed output will go to the reset of the do n. We are going to connect the for each loop array index output to a switch on int node. So that is switch on int, and we connect the exit of the do n node to the exec input there. I've removed the default pin, we don't need it, and I made sure that I have 8 outputs in total for this. That sets a maximum limit on how many assets we can process through this array, so our array size is going to be able to accommodate up to 8 layers of sound. And then it's just a case of going down through each one of these and doing exactly the same thing each time. First of all, we need to make sure that we have our audio components, so that's add component and then audio. Don't have anything selected in the browser because we don't want to populate that. We just want a blank audio component, nothing in it. If you name it track 0 or audio 0 or something like that and press Ctrl and W, it will duplicate it all the way down until we have 16 in total. So first one 0, last one will be track 15. We hook it up one at a time to a set sound node. Set sound node. The exec in corresponds to a number down here. The exec out will go to an add array node. The audio component is an input of that node, and the array is going to be our stored sounds 1 array, our audio component array we created a moment ago. The new sound, that input, gets hooked up to the array element of the for each loop node. After doing it for group 1, we need to do the exact same thing for group 2. We are again linking it back to we are linking it back to the array elements output of the for each node into the new sound, and this time we've gone steps ahead. We're now track 8 and we're storing it in stored sounds 2 array. So we've got 0 to 7 and 8 to 15. And we do that for each of the switch on int outputs until we're finished. This is the tedious part, but it gets us the result that we need in the end, and we only have to do it once, which is great. So just to clarify, I've called my audio component array stored sounds 1 and stored sounds 2. You can call them whatever you like though, whatever's easiest for your project. Once you've got both banks done, we then need to move on to the second output of our sequence node. So trail that down, and it's the same thing. The differences are though that we aren't making as many, which will be a relief, and we're using different inputs. So it's a one-off sound set as a sound base, editable, so we can drop sounds in from the content browser. Same setup, going into the exec, going into the for each loop, one-off sound going into the array and into a length node, that being compared to the array length, the array index, going into a branch from the loop body. Length also going into a do n node, false output pin of the branch going into that enter node, completed output of the for each loop going into the reset input of the do n node, array index from the for each loop going to the selection of the switch on int node, and this time we only have 2 outputs, no default again, and this time we are setting a one-shot sound 0 audio component here and a one-shot sound 1 audio component, both of which are getting stored into the stored one-off sounds audio component array. And of course the new sound is connected to the array element of the for each loop. Nice and easy. We don't need a second bank for this because we are not loading it in after it's finished playing. With the music, we need the second bank to load up when the first one is still fading out, basically, when its natural reverb is trailing off. For the one-shot sounds, they're only happening once at the beginning of every round, so it's not necessary to have a second bank for them. One thing to point out, one thing to mention, is that we've got a limit on these groups of up to 8 entries. There's nothing preventing us from dropping 50 sounds into the array, but this blueprint will only get 8. We'll only get the first 8 of those entries. When I say the first 8, it depends on how they are dropped into the array. So if we drop our blueprint into the map, we get our music, and we say, okay, 1 all the way along here, I'm going to drop that into the sound set. First entry on the list, number 1. Last entry on the list, Unreal Tournament Announcer. Unstoppable! Of course. If we clear that out, if I do this, say I do that, and then I think, oh, I need those as well, and I drag this in, and now our one shot is first. So whatever we select first in here, that's the order it's going to be dropped into here. So that's something really useful to bear in mind. If I go, okay, free one shot UT announcer stem 1, free one shot UT announcer stem 1. Whatever order you select the assets in the content browser, that's the order they will fall into in your array. Once this is all set up, we can go back to our main blueprint, we can go back to the event graph, and we can hook that up to the set beats per minute node. So it's the first step of this new section here that we're working on. Next, we'll add a play quantized node. So play quantized, it'll probably try to stick you to one of the audio components we've added in. We can delete that, because our target for this one is going to be stored sounds 1. The in clock handle is going to be the cached reference to our music clock reference we made before. The in quantization boundary, that input, is going to be a new node called make Quartz quantization boundary, which is just that one there. And this basically tells Quartz what to count when it's looking to play this sound. Is it counting bars, beats, or subdivisions of beats? So that's our quantization bit here. Multiplier tells Quartz how many of those things to wait for before playing the sound. Are we waiting for the 4th bar, the 10th beat, and so on? The counting reference gives us 3 options. So bar relative. Do we mean the 2nd beat of the bar? Do we mean the 1st beat of the bar? Transport relative. Do we mean the 5th bar of the music? Do we mean the 5th beat of the music? That is the 5th beat or the 5th bar since the Quartz clock started ticking. Current time relative. Do we mean the 5th beat from this point now? So if we are already on beat 10, I want to do this from beat 5, it's going to add 5 more beats, or it's going to play the sound 5 more beats ahead of where we currently are, so on beat 15. Next, we're going to promote the in-fade volume level to an editable value, which I've called music volume level, with a default of 1. And lastly, from the in delegate, we are going to drag off event dispatchers and create event. From the drop-down menu, we'll select create a matching event, and that'll give us a new node, and it'll spin you halfway across the blueprint as well. But when you get back to where you would like to be, you should see something like this. I've called this queue status. By default, all Quartz clocks are inactive, so we need to tell the clock to start ticking. And so we're going to do this in this case by telling it, if there's a sound queued, resume the clock. So the sound is queued because we have this play quantized note, so that's saying, okay, I'm ready to play a sound, and that goes, oh, there's a sound ready to play. Ping goes off to this node here, and that emits a pulse from here. From the event type, we want our switch on eQuartz command delegate subtype, which rolls off the tongue. And from queued, we want resume. We want resume clock. Untake context sensitive. Resume clock. And the target is going to be our cached reference to the music clock ref we created earlier. So that is our first play quantized node set up. But of course we need to establish the one-off sound. So what we can do is we just copy this, all except for the create event section. We just paste it over here. Same thing, bar 1 transport relative, just as we have over here. We've got our music clock reference. This time our target is the stored one of sounds array, that audio component array. Music volume level is in the in-fade volume level. Lastly for this section, we are going to add a subscribe to quantization event node. from here, subscribe to quantization event. The target is going to be our music clock reference, and this node is basically our metronome. It will tick along at the interval that we set in this drop-down. I've selected beat, and that means that by using another custom dispatcher over here, we'll get an execution pulse on every single beat. So if we mute everything, I'll show you this next section down here. Go back into our main view, press play. If we go into our death music BP, you can see the beat pulsing along in the blueprint. If we change that to, say, an eighth note instead, so an eighth note is half as long as a quarter note, so it executes twice as fast. And you can see there the pulse speed is different. Now this is going to have an effect on the way that Quartz counts the beats in the bar. If we use the debug section here, we can see that beats is nice and regular. We're using the eighth notes at the moment. 1, 1, 2, 3, 4. If we change this to a dotted half note, you can see that our response is different. It's counting the beats in a different way because it's waiting for a different note length. What we set here will change how our execution pulse behaves in the blueprint. If we wanted to use Quartz to drive a puzzle game, for example, and we had things moving around in a level, we could use that eighth triplet beat to get a different rhythm rather than just your static 1, 2, 3, 4. So from the on quantization event, we're going to pull off. We're going to take that event dispatchers, create event, and this time we're going to create a matching event. This time I've called mine play sounds, which is where we were over here a moment ago. So in this section, this pink section here, we're going to tell Quartz what to play before the current music ends. Now there's more than one way to do this. We could use the switch on eQuartz command quantization node here, which is sort of like a gate node in that whatever pulse goes into it, only a matching pulse will come out. So if we have our quantization boundary set to beat, we will only be able to get out an execution on the beat value. Anything connected anywhere else won't work. But I'm not going to use that because that feels quite restrictive. Instead, we're going to use flow controls to contour and shape the type of pulse and beat that we want. So we'll set our subscription. So I'll make sure our subscription here is back on beat. Yep, which it is. And on the play sounds node, we're going to right click numbars, and we'll promote that to a variable which I've called current bar, and right click on beat and promote that to a variable which I've called current beat. We'll use these to drive some logic further on in the blueprint. Next, we want to add a sequence node with 3 outputs. To the upper pin, we're going to add a gate node. From the second output pin, we're going to add a branch node. The calculation here is our current bar, our new variable, mod, the length of music in bars. So we need to create a new variable for that. So you can right click so to get the mod, by the way, just type in mod or use the percentage sign. And we can right click on the low entry, promote the variable, and we want to call this one length of music in bars. That needs to be editable. And again, it needs to match however long your music is. In the music I'm using in the demo, and the music you can download in the link below, the music is 24 bars long, so our value here is going to be 24. You'll need to adjust that manually for different lengths of music. I'm going to connect the modulo, this is also known as a modulo node, we're going to connect the modulo node to an equals with a lower value left at 0 and plug that into the condition of the branch node. The mod node is a perfect way of telling Quartz when to loop the music. When we reach bar 25, we want to already have queued the second music array, stored sound 2, so that it will play at the start of bar 25. The mod node divides the upper value by the lower number and rounds the value that's left. That works no matter how big the upper number gets. If the game went on and on and on and on, and we got up to something crazy like bar 3480, well, 3480 mod 24 is 0. And in this section of the blueprint, we're telling Quartz to prime the sound and play it at the start of the next bar. When mod 24 is 0, queue up the next piece of music and get it ready to play on the next bar, bar 3481, and it will do it. We can cycle infinitely, and every time the current bar value is divisible by 24 with no remainders, Quartz will be primed to play the next sound array. So we're going to connect the branch's true output to the open input of the gate node, and from the false output of the branch node, we're going to add a sequence node. The first output of that sequence node should go to the close input of the gate. Next, we'll add a do once node from the exit of the gate, and the reset pin is going to be linked to that second output pin of our sequence node. We're also going to take the start closed option there on our gate. So the reason I've set it up in this particular way is that we want the gate to open only when we're at bar 24. We only want to let one execution pulse through. Because we're subscribed to the beat and we have 4 beats in every bar, we'll get 4 pulses going through if we open that gate. Using the do once node means that we don't get all 4 beats of bar 24 traveling through this section. The risk is that we may end up telling Quartz to play array 2 and then array 1 before it's ready to move back to array 1. Going back to our original sequence node, from the third output pin, I've added this print text node with a debug section here, which you can copy down if you like. You can use the curly brackets to define your own input labels, and you can see I've hooked these values up so I can keep track of what's going on. So I want to see what current bar and beat we're on. This we'll get to later. And I want to see what current bank we're playing, whether it's the array 1 or array 2. Again, we'll get to that later. I've also put in a reference to the music clock. Into the print screen input of that, I promoted that variable and called it debug, and I made that editable. So, going back to our do once node. Got a little mini debug section here, which is just to confirm when the next array has been loaded. Next, we're adding a flip-flop node, and this is the bit that will switch us from one array to another. So we can just copy and paste down what we had earlier on when we had our initial sound playing. Everything again except the create event section, we don't need that. And we'll hook one of these up to the A output of the flip-flop node and a duplicate to the B output. Because we are starting to play the sounds from stored sounds 1, our A output is going to be stored sounds 2, and our B is going to be stored sounds 1. Our Quartz quantization boundary, bar 1 transport relative, music clock references, and the music volume level as well. You can see as well that I've got the current bank playing a variable here, which is an integer variable. So we can create a new variable for that. So that's add new variable and then integer, and I'll just name that current bank playing. And for the top one here, linked to stored sounds 2 array, that's 2. And for stored sounds 1 array, that's 1. When we come to start a new round, we'll use this value to select the alternate array to load in. Depending on your project settings, it's possible that we might still be fading out the current array when we start a new round. So to stop it from cutting off, we'll load in a one that wasn't just playing. And that is our Quartz section done. All of the pink sections complete.
Unstoppable.
We're going to leave it here for this first portion of the video. In the next video, we'll look at the other sections of the Quartz blueprint, going through the blue and orange sections. We'll also have a look at a motion tracker, using the Quartz impulses to play different rates of beep depending on how close nearby enemies are. For now, take care, good luck making your own projects, and as always, thanks for watching.